So welcome to my channel. Young's modulus of a steel is 1.9 into 10 raised to the power 11 Newton per meter square. So we will write it firstly what is given. Young's modulus of steel 1.9 into 10 raised to the power 11 Newton per meter square. Moreover, 1 Newton is equal to 10 raised to the power 5 dyne, and 1 meter square is equal to 10 raised to the power of 4 centimeter square. Okay. From question, we will have to find it means this Young's modulus in terms of dyne per centimeter square. That is CGS unit of dynes per centimeter square. So we can write it YS is equal to 1.9 into 10 raised to the power 11 Newton per meter square. Here we can see easily that 1.9 into 10 to the power 11. This is Newton, means 1 Newton, and 1 Newton, which is equal to 10 raised to the power 5 dyne. So we will write it 10 raised to the power 5. And this is per meter square, means 1 meter square is equal to 10 to the power 4 centimeter square. Means we can write here, because it is meter square in denominator, so we will write simply here 10 to the power 4. Now this will be converted into dyne per centimeter square. Okay. So finally we will get YS is equal to 1.9 into 10 raised to the power 11 plus 5 means 16. But here 10 raised to the power 4, it will go in numerator, then it will be negative. So it will be 1.9 into 10 to the power 12. This is YS, means we have the answer in dyne per centimeter square. So it would be option C. Option C would be right answer. Now, further question number 12. If momentum P, area A, and time T are taken to fundamental quantities, then energy has the dimensional formula. Okay. So we know that what W is equal to F dot S. We can write it as F has dimensional formula MLT minus 2, and this is distance, so it would be L. Okay. Simply we can write it as a because we know that we will have to convert it in the form of momentum and area and time. So we know that P equal M into V, and it would have dimensional formula M L t minus 1. So we can write it as a m L t minus 1. 1 t will be left, so we'll write it as a t minus 1 and 1 L2 is left. So see, now we can write it as W is equal to P and LT minus 1. It is that. P and you know that area would have L square dimension formula. So for L we can write as a raised to power 1 by 2, squaring on both sides. Not squaring, if you will divide by 2 on both sides. So this L a raised to power half, and this is t minus 1, so it would be same t minus 1, so it would be dimension formula. Means our option would be option p1. We can simply write as p means t raised to power 1 a half and t minus 1, so option D would be the right answer. Now question number 13. Question number 13. That is saying that on the basis of dimensions, decide which of the following relations for the displacement of a particle undergoing simple harmonic motion is not correct. It is saying that which is not correct. So students must see that. Okay. So we'll check one by one all the options. That LHS and RHS. Uh, that left hand side and right hand side both are equal or not. So option A. Y is equal to A sine 2 pi t by t. Okay, here LHS y equal L because it is simply distance, and RHS A is simply also length and angle. This is simply constant, and this is t upon t means simply t raised to power 0 means 1. So we can easily see that this is L, this is L, both are same. Now option B we will check. Y equal A sine 2 pi sine Vt. It is simply that Y is same again, LHS, it would be L, and RHS, it would be A, which is equal to L. And again for Vt, it is simply velocity time, and we know that V equal d upon t, So it is simply D cross T, so B into T multiplied, then it will give output as a L. So again we say that L, 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 and means they are same. So option C we would check. Y is equal to A upon T sin T upon A. This is LHS. Y equal L and RHS. So this is RHS A upon T sin T upon A. This is simply length, this is simply time, so it can be written as L upon T. It would be LT minus 1. And here T by A, this is angle, so T upon A, T by L. It is simply can be written as TL minus 1. So this is different like that, because in LHS it is simply L and it is simply different, LT minus 1, TL minus 1. So this option is right. And option D, Y is equal to A root 2 sin 2 pi T by T minus cos 2 pi T by T. This is simply angle, and this constant 2 pi, and this T, simply T will be eliminated in this also, so only T raised to power 0 will be left inside. So it would also be length, so this is also length. This is also length. So this is also same, so only option C would be right answer. Now question number 14 is that option A, firstly we will read it also. If P, Q, R are physical quantities having different dimensions, which of the following combinations can never be a meaningful quantity? Out of these four options, we will have to find that which option would never be meaningful. So first of all, we will check first P minus Q divided by R. So one by example, we will understand it as mass minus length divided by time. It is not possible. Never possible. Never possible. Now option B, PQ minus R. So as for example, mass into length minus time. It is not valid. Not valid. But if P will take pressure and Q as a volume, and R as a energy. Okay, then it would be energy, which is perfect. This is which is perfect. Now means option A is perfect because it is asked never possible. So according to question it is right. Now I will check for option C. Option C. Option C is that PQ upon R. Here, if P is mass and Q as a velocity, and R is time, like mv upon T, that is simply a force. It is always possible. Always possible. Now option D we will check. PR minus Q square divided by R. So simply like mass into time minus length square divided by time. Okay. So simple is that could be possible. Could be possible. Now option A. It is simply like option A. R plus Q divided by P. It is never meaningful. Never meaningful. So option we can say that A and E. Option A and option E. They are not possible. So E and A both are identical. Now question number 15. It is simply 15 number question is that photon is quantum of radiation with energy E equal h nu. So now question number 15. Photon is quantum of radiation with energy E equal h nu, where nu is frequency and h is Planck constant. The dimensions of h are the same as that of means the dimensional formula for h, whatever would be out of these four options, that will fit for which we will find that. So one by one. So first of all, we will find the dimensional formula for h. So h is equal to, what is that? E divided by nu, means it can be written as also E T. Okay, so h is equal to E. Dimensional formula for E would be ml square t minus 2, and it would be t. So finally we will get ml square t minus 1. So we will check one by one. Option A, linear impulse. So it is denoted by capital J f into t, f m l t minus 2 and t. It would be m l t minus 1. So it is not as same as, so it would be wrong. So option B now we will check all one by one. Angular impulse, it is denoted by j theta. It is denoted by j theta, which is equal to torque means tau multiplied by t. It would be tau means f into d, f into d into t. F is that m l t minus 2. It is L and it is T. It would be finally ml square t minus 1. So it is fitting to this option. Ml square t minus 1, ml square t minus 1 means it is right. Now option C we would check. Option C is that linear momentum means P. P is equal to mv and vlt minus 1. So it is not same, so this is wrong. Now option D, angular momentum, it is denoted by L, that is equal to R cross P, means Rp sin theta. Simply that L is length L and P is that simply we found already mlt minus 1, mlt minus 1. So we will get ml square t minus 1. So this is also right. So option D and option B both are right answer. Option B and D. Option B and so today's session ends here, and enjoy this session, and don't forget to like and subscribe. Meeting you in next video. Thank you very much.